Good morning and warm welcome. Can you hear me? Great. Yeah, you're listening to music. So my name is Afzal, and working officially currently still at Deutsche Telekom, but in between jobs, I have been working in cellular IoT for the last couple of years. And my side job is doing panel discussions at the Things conference. And today we are going to talk about the future of hardware and embedded engineering, right? Yeah, that's it. But before doing that, let's start with an intro. So I'm going to hand over to Brandon.
All right. Hey, I'm Brandon Satrom. I'm the Senior Vice President of Product and Experience at Blues. We are a IoT connectivity and platform company, and we build modules for connectivity in cellular, Wi-Fi, LoRa, and satellite. And I've been with the company for about 5.5 years, and in IoT for about 10.
Hi, everyone. My name is Michael. I'm CEO and co-founder at Embedded. We are bridging the gap between hardware and software, enabling you to write your custom application on custom hardware, sort of generating the layer in between. We are a startup company, been around for 3 years, and are focused on that hardware abstraction layer.
Hi, my name is Xose Pérez. I'm product owner at RAKwireless. It's a LoRaWAN manufacturer from China. The company has 11 years, and I've been working for RAK for the last 5 and something years. I'm responsible for all the products based on Raspberry Pi or compute module that we have on RAKwireless, which are developer and integrator gateways for LoRaWAN.
Great, thanks for the intro, guys. And it's a bit odd because I'm used to have panel discussions with Brandon where we talk about connectivity, and he has great opinions about connectivity. But today we cannot talk about that, unfortunately. But hardware is also cool, but hardware is also hard. And I know that we should discuss the future, but I want to start with this moment, the now, the present first. The last couple of years, I entered this world of IoT in 2017 when we were launching the first narrowband IoT and LTN networks. And since then, I have seen many companies, not only in cellular, but also in LoRaWAN, trying to make hardware development more easy. And today, for example, I met the guys from Walter, DP Technics, and what they do, I cannot describe it off the top of my head. So it's a small form factor IoT system on module that combines a powerful ESP32 system on chip with a second generation sequence chip, a 5G modem, and a GNSS receiver. And the way how I perceived it is that it's like a device that when you start with it as a prototype, it's also ready for scale right away because the form factor, it doesn't change, which sounds amazing to me. And I've seen many of these initiatives, and there is some overlap with even with Blues, not fully, but some. And I wonder, because I've seen many of these initiatives, is this also what developers want? Because one other thing that I know about developers is that many of them, they don't want you to make things easy for them. They want to try everything themselves, figure it out themselves, and make their own detailed technology stack choices, hardware and software. So what do you think?
I think that it's true in part, but there are other parts where we, as enablers of technology, and I know RAK is definitely in this same boat as well, is that if we can provide consistent interfaces for developers, it gives them the ability to try all those things themselves without reinventing the entire stack. There's things of that are true on the software side, but on the hardware side, one of the things that we've observed, and this is sort of the way that Blues functions, RAK does this with their WizBlock ecosystem, is providing compatibility between radios. And so what DP Technics is doing here is a very similar thing, where if you have a multi-radio solution, you can start with Wi-Fi, you can deploy with cellular, start with cellular, use satellite as a failover, which is something that Blues is a big believer in. But as long as your form factor is consistent, your API is consistent, I think you give developers the tools to make their own decisions, to prove it for themselves, and to figure out what they're going to deploy with, but not to be tied into, well, if I'm going to deploy with cellular, I have to start with cellular, right? You can make that decision earlier in the process, but you have the full control to decide where you want to go and the flexibility to do so. And I think modular hardware is really powerful in that regard. And I think modular software absolutely helps to accelerate some of that as well.
Yeah, sure. I think for us, we obviously sit at a very different level of hardware-software integration. I think we've been seeing a value add shift where it's less and less that you can add as an engineer in mere integration of a component into the project. The value add sits within the application layer. So, and we are definitely seeing across the board eagerness from developers to find standardized solutions with initiatives like Zephyr to find a way to easily integrate hardware with software. So I think there is a trend that goes there, but just before we started this, we had this small discussion about Zephyr and why that adoption is not yet happening. The question is, how do we migrate and port everything that we already have? And the approaches we are used to implement in organizations into this new world where we need to find standardization, when we need to find approaches for fast integration and focus on that application layer.
Yeah, I completely agree with you both guys. I also feel the pain of the developer that, and it's what he or she should do, like testing absolutely everything that's out there to find out what's going on and what is the best option maybe. But in the end, we are seeing a trend towards standardization, which is good and bad at the same time, because there will be less options that are really standard. But the overall moment is pushing towards more security, better connectivity, to maintenance, which I think is one of the key points in the future. We are not talking only about batteries that we don't want to die too early, but about everything related to maintenance. And all this stuff is pushing towards standardization. So this is something that, from a modular point of view, which I'm always up to because that's what I feel like it should be, it's always a challenge as well. So how to create something that's really modular, that you can move from one solution to another, being connectivity, being sensors, being whatever you want to change, but really something standard that follows some principles that you can maintain in the future, that you can, and this is about a lot of different stuff. So it's good for the developers to know all this stuff, what is happening in the world, but then I fear they will really have few options. So, and just like in any other market, these few options might not be chosen might not be the best options that we really have now. There will be other reasons why we finally end up with X, Y, Z solutions. So, developers should try everything just to see what's missing from what they have to use.
Got it. Thanks. So we need basically both. We need to make it easy for them, but we also need to make it hard for them. Before going to trends, let's put it differently. When we talk about trends, I mean, we're in this already for a long time, right? And I like to talk about trends based on what we've learned, our failures, our successes of the last decade. So I just wonder if we concentrate this discussion on low power wide area IoT, what should be the trends in hardware and embedded development?
So it's a good question. I think there's two answers I would give. One, on the connectivity side, it is abstracting away. Actually, the theme of both would be eliminating complexity, where developers just are done with the pain of dealing with a certain complexity, whether it be on the hardware side or whether it be on the design side. And so a lot of the complexity in hardware, especially around IoT, is dealing with connectivity modules. So even if you want to work with Wi-Fi or work with cellular or satellite, it is the direct interface with a module that ends up creating a lot of pain for an engineer. You're trying to build a business application and you're finding yourself spending a lot of time writing AT commands against a module. That's not a lot of fun. I know that we like as engineers to solve hard problems, but I think we also recognize when a problem can be solved for you and you get that abstraction, it's like, that's great. One less thing I have to worry about. And so that's one piece that's very interesting. On the hardware design side, I think it comes down to one of the most painful pieces of hardware design is that early part of laying out a board and dealing with schematic capture. And I think where tooling, and I know we'll talk more about trends, but one of the things that I find fascinating in the tooling side for hardware design is being able to get to board layout faster because schematic capture can be automated. Because you can lay out your board, you can describe at a high level what you want your board to look at a function, what you want it to look like at a function level, and then have that schematic generated for you. So the painful pieces are there. You move on to layout, you move on to the more, as a hardware engineer, the more fun pieces of building a product. And so in both of those cases, whether it's working with a module directly or designing a board, it's about abstracting away the necessary pains of the past and giving engineers the ability to move to the next step faster. And I think that's true in doing software, and definitely what Embedd does as well. There's another piece of that, I think.
Yeah, 100%. I think sort of ensuring robust hardware abstraction in software is one of the sort of priorities. And the last 10 years with shortages just highlighted that you need to have a robust supply chain and you need to have agility in the process, where I might not be the most popular opinion here, but ability to swap between modules of different vendors, ability to have that done in a short time cycle could be very valuable to companies. I think we've seen situations whereby productions are halted if a supply chain of a supplier sort of is affected in one way or another. And I think a lot of OEMs are trying to find ways where they can easily sort of create that hardware abstraction layer that will allow them to maintain stable APIs and maintain stable sort of access to capabilities of a module, because they often would be sort of very similar in principle, without having to rewrite their application layer to be able to integrate that new component. And that's sort of what we are seeing now is, on one hand, there is a shift towards that. At the same time, I think a lot of vendors, especially old school vendors, are sort of trying to oppose that and create lock-ins that are not great for the ecosystem.
Yeah, so for us as RAKwireless, so our motto is made IoT easy, and it's so complex to make IoT easy. So answering Afzal's question is like, we noticed what went wrong with deployments that we had, with customers that we have, what failed, because yesterday I was doing a keynote about, gateways, you plug it in and it works, right? No, it doesn't. So most of the time there are issues. Things happen, some of them do not depend on you, but you have to be reactive. You have to be able to solve that. Just as an example, for instance, you were talking about hardware designing. We've noticed that you cannot pretend to start by having an MCU, program something on it, attaching a sensor, and then you will take care of the enclosure, the antenna in the end. No, that doesn't work. You have to you have to think about all this stuff from the scratch, from the beginning. You have to think of where the antenna would be, where will the device be deployed, so how the antenna will be interacting with other things around the device. The enclosure, how do you place the antenna, how do you place the device, where is going to be the battery. So a lot of stuff that it's not only about the schematic only, you know. You have to think about so many things from the beginning in order to have a potentially successful product, let's say. So that's what we've seen. It's really complex to tackle all the problems that you will have if you don't think about them from the beginning.
Thanks. And you made me curious because you said something about swapping between different vendors. And this is the first time that I hear about this, because from my experience, I mean, I see that, like with the customers that I've worked, I saw that it was quite consistent. Maybe the type of module was different. So they started with, for example, a Simcom X point 3, and a couple of years later they switched to X.6, something like that, but not from Simcom to Quectel or from Telet to uBlocks. And I thought that this was something easy as replacing a SIM card. So my question is two-sided. Like, what could be a reason for swapping from module vendor, and does it happen a lot?
I think there are a number of reasons why this could happen. Obviously, the one we just mentioned is related to supply chain. So if you don't have availability of a particular module and the other options that that supplier can provide doesn't work for you, you need to be able to port. The second part of this comes from conversations that I've been having with purchasing departments in larger OEMs, where they effectively ability to easily swap between vendors and shift to new vendors creates additional sort of purchasing power in negotiations that they might have around cost of modules. Often we see software lock-ins, whereby a software package is provided for a specific larger vendor, larger OEM would make it really hard for the customer to shift, and sort of blocking them from going away. And then obviously commercially that's not the best position to be in as a customer of that company. But that's a major trend that's been out there for decades, where all of the tooling that vendors normally provide is designed for you to try and remain within the realm and ecosystem of only that specific vendor and not go anywhere else and provide no cross-compatibility. While the reality of devices is that we have all of the different manufacturers on the board, and we need to be able to work with everything. So if that answers the questions, really.
Yeah. Can I add to that? Yeah, I have an opinion here, because the other factor that is. Well, it is, because the other issue that we deal with as a company that's U.S. based that operates a lot in the United States and in Europe, the geopolitical risk is a big one right now. I mean, the reality is that when you source modules from countries or regions where there's a potential issue of modules from that country being on a ban list, and now you can no longer sell to certain state and regulatory bodies, that becomes a challenge. And so Michael's right. A lot of the ecosystem is built around locking you in, not just on the hardware layer, but also on dealing with the fact that an AT command is not an AT command is not an AT command. So if I switch from a Quectel to a Telet module, and we have in our booth here on the floor a couple of our firmware engineers that can tell you exactly how painful it is to deal with AT commands from Quectel to Telet or what have you. You're making that change. It's not just the pin, it's not just a new board layout, but it's dealing with doing a cell scan and connected to the network. It sounds like it would be easy and the same, but it's not. And there's a whole nother code path you have to work with in order to do that. And so that's another area where you get resilience not only in having software tooling that allows you to have that flexibility, but also working with modules that offer an abstraction layer on top of what you get out of the box, right? And so software and firmware abstractions around connectivity are an important thing to look for as well. So you have that flexibility. You de-risk your supply chain, not just for supply reasons, but also geopolitical reasons. And that can be pretty powerful for an engineer to have that flexibility.
Yeah, that makes a lot of sense. Thanks. And with regards to AT commands, it's not even possible to find the documentation very often. Yeah. Okay, let's now spend some like the last 5 minutes of 6 minutes of this session on trends. And I wanted to avoid cliches, but still, some people asked me yesterday that they are curious whether AI is already playing a serious role, even in hardware development. And embedded engineering, or if it could play a serious role. So you don't have to. So tell me your favorite trends, the trends that you encourage, and also tell if there is a role for AI. I will start with.
Yeah. So I'm not going to say much about AI. I think they know much better than I do. Of course, it's a buzzword, and everybody's talking about it. maybe the thing is that everybody's pushing to AI things, and we are lagging in maybe other trends that might be equally or more important. For me, yeah. So aside from AI and of course power efficiency, because LoRaWAN is always about power efficiency, which is always kind of something you have to take care with devices. There are two major trends that one of them is mostly it's coming. Everybody says it's coming. Is like security in Europe, CRI, and this kind of stuff is going to. It's already here. So we have to provide an answer for that. So security is no longer something that we talk about and do nothing. It's going to be something that we have to do something about. And the other one is maintenance, like I said before. It's not only about how long your battery is going to last, or if you can scavenge power from something around the device. It's going to be much more than that. It's going to be how you can manage the device remotely. Even for low power devices, we did a workshop about FuOTA right now on LoRaWAN. So all this kind of stuff is related to the security as well, because this is going to be mandatory. But all this maintenance on the device for all its lifetime, it's going to be a huge thing in the next years, I think. AI for you.
Yeah, I'll shamelessly talk about AI. And I think AI ultimately is a big unlocker. But the question is that we should take a step back and from first principles think where it could be applied, where it makes sense, and where we shouldn't apply it. And where we should apply it is when we chuck in a huge context with tens of thousands of pages of data sheets and erratas and SDKs and try and ask it to spit out some code. A code that will by no means be stable or predictable or can ever function in functional safety environment. What we've realized, and that's sort of very specific to hardware-software integration, is that the problem is not about software engineering. Hardware-software integration is a data problem. And the data problem sits in the fact that we have heterogeneous data sets of data sheets that are not stabilized even within a single vendor. These are PDF documents manually written by humans. We have low quality, let's put it this way, samples of code. We have SDKs here and there, but all of that is all over the place and by no means standardized. The problem in the integration is not the fact that we need to generate code and that in fact we can't generate code deterministically. The problem that the inputs are not in the right place, and AI can actually do quite a big job in assisting us in arranging and structuring data to create stabilized machine-readable representations that can then be used to deterministically generate code and solve the problem of hardware-software integration. So it's like a slightly different view on things, but I think there's a place for AI for sure, but we just need to carefully think where it is.
Yeah, I really like that. I think the idea of creating better inputs to yield better outputs is a piece of the forefront that will benefit engineers long term. And on the output side, I think what I have seen is that firmware engineers, hardware engineers that make most effective use of AI don't give AI complete agency over the work that they're doing. They treat it more as an assistant than an agent. One of the things that I've read a lot that I sort of try to personally practice is that if you're using ChatGPT or Claude Code, we use Claude Code a ton internally at Blues. I use it almost every day as well. Is that I don't allow Claude to do anything that I'm not willing to own myself, that I'm not willing to read, that I'm not willing to take some accountability for. And so if we have engineers that use Claude to generate 10,000 line pull requests and they're asking someone else to review code that they haven't reviewed themselves, that's an anti-pattern. And so we're learning, we're figuring out how this works. You can accelerate, but don't try to move so fast that you make the wrong decisions, that you assume that, like Michael said, the inputs are so good that it's really just a matter of, hey, you can figure this all out from the data sheets. With bad inputs, you get bad outputs. But with having that idea of, hey, this is going to help me move faster to get to starting somewhere 80% of the way there, but I own the last 20% to make sure it works, to make sure I've tested it, to make sure I'm proud of it, that it is the code that I would have written otherwise myself, just faster, then I think that ends up becoming a real level up for a lot of engineers and a lot of organizations.
Thanks. Thanks for sharing your trends and your thoughts, and also for keeping it down to earth, say, by not talking about AI. Our time is up, so I want to thank you for the great conversation. See you next time.